What's up, team? Today we're talking sectors and arc lengths, learning target right here. I can find the area of a given sector as well as the length of an arc of a circle. So let's talk about what these things are and then how to find them. So here's some circle. We have a region over here that's shaded in. We call that a sector. So think of a sector like a slice of the circle, like a piece of pizza or something like that. There'll be all sorts of different sizes. This one happens to have a central angle of 90 degrees. That's not always the case. You'll know what the central angle is or know how to find it. And this one just happens to be 90. It'll be nice and easy to work with. We have a radius of 6 centimeters in this case, and then we have a couple points on the side of the circle A and B. So the first thing we're going to approach is finding the area of the shaded sector. So what we're going to do is we're going to do this in 2 steps. The first thing we're going to do is find the area of the entire circle. So we know that the area of a circle is pi times r squared. So for us, we know that our radius is 6. So the area of this thing is 36 pi centimeters squared. Cool. But we were asked to find the area of the shaded sector, not of the whole entire thing. So that's where we dive into step 2 here. We are just going to set up some ratios here. We know that the whole entire thing is 36 pi, and we are trying to find r. So we're going to say the area of our sector, like the shaded sector over there, over 36 pi has the same ratio as, well, what we're going to do here is going to examine the angle measures. We know that this is a 90-degree angle, so we are taking up 90 degrees of the circle. And the circle, all the way around, every circle ever, has a degree measure of 360. So we're going to put that 360 in our denominator. So we're saying the area of our sector is to the area of the entire circle, as the angle measure of our sector is to the angle measure of the entire circle. And then we'll do a little bit of cross multiplication here. We'll learn that 360 times x equals, well, whatever 90 times 36 pi is. I'm going to grab my calculator, and I'm going to type in all this madness and see where we go. So I'm going to do 90 times 36 first. 90 times 36, and that is 3240. So 360x equals 3240 pi. We're trying to solve for x here. We're not trying to solve for pi. Remember, pi is just some number. So I'm going to take this 3240, or actually I'm going to take the whole left side and the whole right side, divide everything by 360, and I learned that x equals 9 pi, because 3,240 divided by 360 happens to be 9. That worked out real nicely. So the area of our sector is 9 pi. We could also say, if we wanted to find a decimal approximation, just type in 9 pi on your calculator, and we learn that it's approximately 28.27, we're talking centimeters here, centimeters squared. So both of these solutions are equally as accurate. Another thing you may have noticed is that 90 over 360, we could have reduced that right off the bat and said 1/4. That would make our equation a little bit simpler. We'd have 4x equals 36 pi. The division's a little simpler, but we get to the same place. So whenever you find any area of a shaded sector, you're going to create a ratio of whatever your angle measure is over 360. 360 is always going to be the denominator, because there's always 360 degrees in every single circle ever. So you always have this 360. On top of that, you have your angle measure for whatever the sector is given. It's not always 90. For this one, it was. And then on the other side, you're going to have the area of the sector over the area of the entire circle. Sometimes you're going to be asked to find this angle measure, but you'll be given this stuff. Sometimes you'll be asked to find the area of the circle, but you'll be given this, but not the radius, or something like that. You'll always be able to find 3 of these 4 pieces. Okay, let's find, oh, geez, this is a new symbol. This says find the arc length of AB. Find the arc length of AB. So what that means is, notice how this is kind of curved. That's on purpose. AB is going to be this arc length right here. So we're going to find the length of just this piece of the outer edge of the circle. So instead of finding the entire circumference, we're just going to find that chunk. All right, it's going to look just like what we did here. But instead of finding the area first, we're going to find the circumference. We know that the circumference is 2 pi r. So for us, our radius is 6. So it's going to be 12 pi centimeters. And then we're going to set up a few ratios again. So it's going to be our arc length over the entire circumference equals, well, it's going to be the same 90 over 360 because we're working with the same sector here. So it's going to be a 90-degree angle over 360. And I'm going to reduce it this time and do 1 over 4. Now, solving for x, we know that 4x equals 12 pi, so x must equal 3 pi. And if we want to grab a decimal approximation of that, it's going to be really close to 10, 9.42, and we're still centimeters squared. Okay, the key thing with these ones is you're going to find either the area of the entire circle or the circumference of the entire circle. Once you do that, you're just going to divide, or you're going to set up a proportion based on how much of the circle you care about. For this one, we cared about 1/4 of the circle. Sometimes you might end up with something like this with an angle measure of like 20 or something. You would do all the same stuff, except for you'd have 20 over 360, and then you'd finish it off from there. Okay, one last piece of the puzzle. This is going to come into play sometimes. Generally speaking, when you see a symbol like this, arc length of AB, you're talking about what we call the minor arc. That's the short way there. So, for example, the minor arc, what we found the length of from A to B, we found is 9.42 centimeters. Sometimes you might be interested in the long way around. We call that the major arc, which would be from A all the way around to B. For our problem, we weren't asked that. You can always assume we're talking about the minor arc, which is what we found. That's the short one. If it specifies that you're looking for the major arc, well, then you're just going in the other direction. And the way that we could do that is, there's a few different ways. For this one, we could say if we know that the whole circumference is 12 pi, and what we found for our minor arc there was 3 pi, that means the leftover is 9 pi. So that means the major arc here is 9 pi, and of course you could grab a decimal approximation for that too. Okay, this is how to find the area of a sector of a circle as well as an arc length using the central angle. All right, let's dive into those practice problems. You got this.